Welcome back to part 3 of the Amiga SICK 100 series. Last time we got my Amiga here sitting beside me. Last time we fixed the audio issue. The right hand mouse button input, that wasn't working, and then magically fixed itself. But there is also the composite issue. We discovered that the little cans that sit beside the video encoder, at least 2 of those had failed. And so rather than trying to muck about with them, this time what we're going to do is swap out that video encoder to a different type that does not require those cans. But it also does require a little mod on the motherboard. We also discovered that the old keyboard, this thing, well, other than the fact it is missing a couple of keys, the ribbon on it is more or less toast. So rather than muck about trying to get that sorted, I just went and bought another keyboard. This one does work fine, although in my haste to take the machine apart again to fit that, well, remember those pesky wires going to the LEDs? 2 of them have snapped off and the other 2 are hanging by a thread. So I think we will also replace these wires with something a bit longer, something a bit easier to work with. In fact, let's start with that. So our green wire, that should be connected there. The red wire, that should be connected down there. But other than just resolder them as they are, I think what we're going to do is replace these with something a bit longer. That is the main problem with this, really, isn't it? These wires are so short, and because where this connects internally, it sort of connects, say, about there internally. And if you bear in mind, the keyboard is usually in here as well. There's just not enough room to be able to get your hand in to get these connected without pulling strain on these points. That's why those 2 have snapped off. That black one is hanging by a thread. So let's just replace the wires. I have some nice long cable here. I think we'll just make them even twice the length of what we have there. And that should hopefully solve the problem once and for all. So we have 4 new wires to replace the old. Just like that. Cut the old wires off, made the new ones onto the back of that. Rather than muck about with this connector trying to get those pins out of there, I instead just cut the wires and then joined them, soldered it on a bit of heat shrink. That'll do rightly. At least twice the length of what it was before, and that should make things a bit easier when it comes to fitting our top case back on again. But what about that composite? So as you know, this board is not producing any composite video signal. As I said last time, composite is just a combination of the Chroma and Luma video signals. Chroma being the color, Luma being the actual picture itself. And it's the job of our video encoder chip to create both those signals and ultimately combine them into the composite. But this particular video encoder, well, this can't do it by itself. Rather, it sends the Luma and Chroma signals out through the cans. There's one of them there. The other 3, well, I say 3, it's one component. It just looks like 3 of those. Sit in there, that position Z222. Well, that is the Luma signal that comes out of this chip through those, then back to the chip. And we discovered last time that we have a fault in the cans that usually sit there. So it seems that you can't get replacements for those. Rather, what everyone tends to do is just replace the video encoder chip with a newer model that does not require these. It also doesn't require a couple of other bits, which we'll get to in a minute. But we need to take that off. We obviously need to take the chip off. To replace that, well, I need to say a massive thank you to Mark Brown, aka Super Duper. No doubt you've heard that name before on this channel, because Mark has came through once again for us and has sent me 2 of the video encoder chips and 2 of the required resistors as well. And just in case you're wondering what could possibly be in this big bit of cardboard that he attached the chips and the resistors to, well, that might give it away. In here is a new membrane for our other keyboard. So thank you very much, Mark, for sending all this my way. This bit here will get our composite video back up and running again. The new membrane, well, that is something that I can have a play with at some point in the future to see if I can get that other keyboard up and running again. But for now, let's get our composite sorted. And the first thing I want to do is just remove this other can. I'll need the desoldering station to do that. That came out easily enough, but as you can see, there is a bit of staining on the board here. Obviously from leaked electrolytic from the previous capacitors, or well, the previous capacitors. And if you want to know what that means, make sure you go and watch the last video. And speaking of the last video, actually, one of the comments on that suggested removing the RF modulator. Now, I will never use this, although I do like to keep it there. But the reason for removing it would be to check underneath it, as when the old capacitors leak, well, underneath here is one place in particular where they can leave a bit of a mess. It's not hard to remove, there's just 3 solder points there, and then there, and there, just holding the can itself on. The other thing though, while we are down here, to do this composite mod, there are a few other components just here that we need to remove. Those 2 resistors at the end there, those 2 capacitors, and those 2 resistors again. But to do that, I can just take my soldering iron with its nice large tip on it, can apply a little bit of fresh solder to either side of the component, and it just lifts away. I will come back and tidy all that up in a minute with a bit of braid, but just let me try and get this RF modulator desoldered as well. It's actually not too bad under there. There is a little bit of staining just down this end, so we'll clean all that up, but I was actually expecting that to look a lot worse. Easy removed though, and easy put back. So a little bit of cleaning up to do there, some cleaning up to do here. I've blocked a hole again, so we will sort that out. We do need to take the old video encoder off, and we will be using a bit of hot air to do that in a minute. But just before we do that, let's clean up what we've done so far, certainly on the bottom side of the board anyway. Just want to clean up around where we removed those components. So just a little bit of flux, and then we'll just use the braid just to wick up any of the old solder that's left. That looks pretty good, although I'm just noticing here, and I don't know if I did this previously or not, but solder point there and there, they look a bit crap. Yeah, that looks a bit better now. So let's get the encoder chip off. Now this would have been a lot easier to do before I fitted all my nice new capacitors. But we just need to work around them, and to save any damage here, and to save blowing off any of these other components, because we are going to be using hot air, to save any of that, let's go in with a bit of our high temperature masking tape. So just before we do go in with the hot air, to give us the best chance of coming off quickly, just going to apply a little bit of flux, and I want to melt a little bit of fresh solder just into those pads. And then we'll just hit it with the hot air. I have this at about 400 degrees, and the airspeed is at about 3/4. And the chip comes off. So we don't need any of this stuff anymore. We'll just clean up our pads again quickly with a bit of braid. And just tidy up what we've done so far. That old chip, just thinking, there's probably nothing wrong with that. So we will just stick that into the spare parts bin. I'm just going to put it out of the way so I don't get it mixed up with the new one. this one, and there's the resistor that we need to put across it. But just before we do stick that on, there is one other modification that we need to make. Pins 8 and 9 here on the motherboard, well, we need to bridge them. And then equally, pins 8 and 9 on this chip, we need to remove them. So it's 1, 2, 3, 4, 5, 6, 7, 8 and 9. So it is those two that we need to bridge. And to do this, I'm just going to use a little bit of wrapping wire. Okay, I think that should be it. And we can just nip this off nice and carefully with the knife. Did I just stupidly cut through that trace? Oh, you idiot. No, that trace is okay. But I did just nick the solder mask off it. So if you're going to be doing this, you know, be careful. Have we successfully bridged those 2 points though? Yes. So pins 8 and 9 on this, we need to remove them. That's those two. And then we can solder this in place. As per usual, we'll just do 1 pin of it to start with. And we'll just double check that it is sitting correctly. And yes, it is. Not a particularly hard thing to solder because the legs on it are quite big. But I'm happy enough with that. So plenty of flux. Did move a little bit there, so just let me anchor the other end. And then we'll just do all these pins individually. I'm not going to drag solder this, certainly not this side, just because if I did, there's a good chance that I'll just lift that little bridge that I put in there on the board on pins 8 and 9. We can safely drag solder the other side though. And that is more or less it. Last thing to do is just fit this resistor. And this goes between pins 12 and pin 17. So we'll do pin 17 first, which is 5 along on this back side. Then we can tack down the other leg to pin 12. Okay, I think that's us. I'm just going to tidy it all up here. And then we'll see if we have composite video. Okay, does it work? Power hooked up, composite hooked up. You'll notice I have refitted the RF can as well. And just gave the top of it a very quick going over with the fiberglass pen. There was a couple of wee spots of rust on it, but that just tidies it up. Composite. Yep, looking good. And you know what? That's actually not a bad picture for composite. Definitely not as sharp as what you'll get out of the RGB, but it's not bad. And if you didn't have an RGB cable, it would certainly do you. Especially if you're just using your old Amiga to play games. I was just in the middle of building all this back into the case, which itself I have given a bit of a clean, and I will show you all that in a minute. But it just dawned on me that while we fitted the new video encoder here, I didn't really explain what's going on, why did we remove a couple of pins, and what is this resistor doing. Well, on the left hand side here we have the datasheet for the new video encoder. On the right hand side here, this is the Amiga 600 schematics. So if we just look over here to start with, as you know, we removed Z222 and Z221 purely because there was a fault in here in the delay line. Z221 is the BPF or band pass filter. But if we take a look on the schematics for the new chip, well, under its features, it says here that it has a built-in bandpass filter for the C signal and delay line for the Y signal. The C signal, that is the chroma. The Y signal, that is the luma. Pins 8 and 9 that we removed off the new chip, well, 9 is not used, not connected. 8 is BF out. I'm not actually sure what that is, but that's an output anyway. Whereas previously on the old chip, if we go back to the schematic, pin 8 carried the audio in, pin 9 carried the audio out to the RF modulator. So strictly speaking, you wouldn't even have to do that. Bridge pins 8 and 9 that is, if you're not going to be using the RF modulator, but we still have our modulator fitted in there, so that's why we bridged those pins. As for installing the resistor between pins 12 and 17, well, pin 12, as you can see, is VCC, or 5 volt. Pin 17 is Y-trap. And if we scroll on down to an explanation of what this is doing. Pin for reducing cross color caused by the subcarrier frequency component of the Y signal, or the Luma signal. When the CV out pin is in use, composite out, that's what we have this in here for. When the CV out pin is in use, connect a capacitor or a capacitor and an inductor in series between Y-trap and ground, blah blah blah. Or the internal trap can also be used. Refer to notes on operation number 6. And if we scroll on down to this, there's pin 17, Y-trap. And it's telling us to install a 2.61k resistor between pin 17 and VCC, just like we have done. Beyond that, this chip and the original are just pin compatible for each other. They pass the RGB signals through, which run on to the RGB port. It just picks up those signals to create the composite. Now, one thing you could do, and some people have done, is rather than refit the RF can, you could fit an S-video jack in here and pick up that Chroma and Luma signal, feed them into that, and you'd have an S-video output as well. I'm only ever going to use the RGB, to be honest with you, so we didn't really even have to do this, but it would just annoy me, the fact that the composite wasn't working, but at least it is working now. Just before we do go ahead and reassemble the rest of this machine though. Amiga 600, 68k processor, and just 1 megabyte of chip RAM. But it does have the 8375 Agnus. You can fit 2 megabytes of chip RAM to this machine without any modification whatsoever. It goes in here in the trapdoor. And I have a kit here to build our own 1 megabyte chip RAM expansion. So how about we just quickly put this together. I got this little DIY kit back when I originally bought that A600. This came from eBay as well. And it wasn't that expensive. I think it was about 10 or 15 pounds, something like that. And hopefully it won't be too hard to put together. There isn't an awful lot to it. As well as the memory, we also add a battery here, a CR2032, for a real-time clock. I think everything we need is in here. Or at least I would hope it is. And the seller has very kindly noted on this what everything is. And hopefully the silk screen is equally denoted. Certainly seems to be on that side. Yes, it is. So where to start? I think we'll start with the surface mounted stuff as always. And I was going to do all the little passives first, but I may actually do the 2 RAM chips first. Because if I put those capacitors on there, well, I think it would just make things a little bit difficult trying to get in to solder the pins of the RAM chips. This type of chip that has to go here actually, this is the one type of surface mount soldering that I don't really have any experience of doing. There's the 2 memory chips there. They are going to go on like that. But as you can see on this type of package, it's almost like a PLCC package. The legs of the chip bend down underneath it. They don't sit out. So getting them soldered in place, it's going to be tricky enough, I think. But we'll just try and do it our typical way. So let me get the chip aligned first of all. And I think that's pretty good at that. We'll go into pin 1 here just with a load of flux. Just try and get that first pin tacked down to start with. I'll just load up the iron with plenty of solder and see about trying to get this stuck down. Okay, I think we're on there. So we'll just turn this round. And I'll try and do this opposite corner. Again, just a bit of flux. And we'll load up the iron with some solder. And try and float it. Well, those two went down easily enough. Let me try and do the rest. Someone said recently that I'm using far too much flux. And while that may well be the case, I'd rather be looking at it than looking for it. It's easy enough to clean this stuff off. Yes, it is relatively expensive, that cheap quick stuff, but I'd rather have it on there just to make the soldering easier. In fact, I need the fume extractor on. So please excuse the noise of the fan. But I think that's that side done. I will come back and look at it again in a minute under the magnification. But let's just quickly do the other side. And yeah, that looks pretty good to me, but just let me grab the magnifying glass quickly. And yeah, that all looks pretty good to me. What about the other side? Yeah, again, I think that's fine. Let's do the other chip. One thing just to point out here, actually, I said pin 1 is down here, which it is, but on the package itself, you can see there are actually 2 large dots there. Now usually a dot like that would represent where pin 1 is, but there's 2 of them on this package. If I tilt it down slightly though, you see that other one down in there? That is the pin 1 identifier. Plus this end of this package is chamfered down compared to the other end, which is straight. So that is definitely pin 1 up here. But just the same thing again. I moved it that time. Okay, I think that's it down. And we'll just do that opposite corner again. And just inspect it all and flow the rest. A little bit too much solder there, but that's okay. Orientation is pretty good, so let's just go for it. Get the rest of it done. Right, that is both of those on, and I've checked it all looks fine. Let's just finish off the surface mount anyway on this side. 6 little capacitors to do. That's them there. And in fact, this is nothing you haven't seen me do a million times before. So rather than talk my way through it, as per usual, let's go for a mini soldering montage. There's an LED on the bottom. Well, I say bottom, I think that's the bottom. But why is there an LED on it? Why would you need a power LED on this? It's included in the kit anyway, so I think we will go ahead and fit it. But here's the question. Which way around is it meant to go? So there is a through-hole capacitor to be fitted here. On the left-hand side pad, looking at it from this side, that is the ground. The LED itself is going to have a polarity, but if we can figure out which one of these is the ground. That's dead short there. That's not. So that one obviously has to be ground. There is the LED. It's really hard to see this. I'm not sure if it will come across on camera or not. But looking at it like this, the right hand side of it has a green marking on it. And that green marking represents where the positive side of it is, I think. So that'll go on there like that. Well, we have another component that has a polarity on it. Capacitor C8. That looks like it's a tantalum. So let's see if one of these pads is ground. I'm thinking it's going to be that one. And it is, yeah. And so that needs to go on like that. You can see a line on it here, but the line on the tantalum, that denotes the positive side. Okay, that is all of the surface mount stuff done. But as you can maybe tell, certainly on this side, it's not exactly the straightest, is it? Especially those capacitors. So just going to hit it all with a little bit of hot air quickly. And as you know, that will just help pull everything into its correct position. Okay, it's just the through-hole stuff to do, in no particular order, so let's just put this on. The real-time clock chip, which comes pre-fitted in a socket. That's nice. Little bit of blue tack just to hold it in place, then we'll go for opposite corners first. Take the blue tack off, and just to be sure that it is indeed sitting flush, I can just push the board down into the desk there. While reflowing those, I'm trying not to melt my finger. And yeah, that's okay. I'm happy enough with that. So let's just do the rest of it. When you're doing the likes of these things, this is the enable jumper. It's always a good idea to put the actual jumper on it. It just helps hold everything together. And also lets you stick a bit of blue tack on it, just to hold it in place. The jumper just gives something for the blue tack to stick to. If it was just onto the legs, well, the heat of the soldering iron would probably just melt its way through it, to be honest. That cap's not sitting perfectly straight, but I can just remelt both legs of it there together. Just push it from the other side with my finger. And then, last but not least, it is just the edge connector. And I assume it must go on the top side like that. Because if we bring in the 600, that will go in there like that. With that on the top side. Yeah, no, that's fine. It still clears everything, doesn't it? In fact, it doesn't even go on the bottom side. It's keyed. It can only go on that way around. Opposite corners again, just to start. And then holding this, I can melt those again and push on the edge connector from the other side, just to make sure that it is sitting flush against the board. So I don't really know what made me check it, but I just thought I would double check the polarity of that LED. I said the green line on it denotes the positive side. Nope, that's actually should be the negative side. I have that installed back to front. So this actually needs to go on that way around. And let's test it. The edge connector here on the 600 is a bit grubby looking, a bit dirty. But we can clean that up very quickly using a rubber or an eraser for my American viewers. Okay, so board going to sit in there like that. And let's see what it does. Green screen. That is a chip RAM error. And you'd have to assume it's this. LED works. Nice bright blue one. So pretty safe to assume that there is power getting to this okay. I suppose the first thing we should try really is reflow those two chips. I mean, they do look okay under magnification, but maybe there is something a bit dodgy in there. I think I found the problem, and I'm not sure how I didn't spot this before, but just at that point there, I mean, it is really hard to see on the magnification, but between pin 7 and 8, or well, that's not pin 7 and 8, but the 7th and 8th pin down on that side, we have a bridge. Just the tiniest wee solder bridge, but it's definitely there. So that is more than likely our problem. Bit of flux in there and then just reflow those pins. And our bridge is gone. So hopefully that fixes it. Let's try it again. Yep, it's booting. Go into Amiga Test Kit. Then if we go to the memory test, 2 megabytes total memory detected. Chip 2 meg, it's working. Let's run a memory test. So yeah, it's been right round there, just once, but you know, if there was any problems, it would have detected it. It's fine. Well, I think that is us more or less finished with this Amiga 600, or certainly finished for now. We've fixed the composite video issue, although I'll probably never use it anyway. I'll only ever really use the RGB. And I must say the RGB signal out of this machine is really crystal clear. It's one of the best I have ever seen. We fixed the sound issue. We fixed the low pass filter. And the problem with no right hand mouse button input, well, that seemed to fix itself, didn't it? Although the consensus seems to be that that was related to the problems with the low pass filter. When I reflowed that whole area, I obviously repaired both of these things at the same time. So we've done all that, plus we have put in the additional 1 megabyte of chip. What else should I do with this machine? Let's just double check that our input is working properly. So controller ports, right hand mouse button, yep, that's fine. What about the audio? Yeah, sounds good. And the low pass filter, that is working perfectly. One Amiga 600 with a clean bill of health. I would test the IDE and I've no reason to suspect that it won't work. But the ROM in this machine is version 2.04 37-175, and that particular ROM, that's the one that within this the IDE is disabled, or should I say more accurately, it is missing the code required to enable the IDE. The 600 was a self-shipped with 3 different ROMs. This one here, which doesn't support IDE whatsoever. There was version 2.05, but revision 37.300. That one does support IDE, but some people have reported that it's limited to a maximum of 40 megabytes. The one that we really want for this is version 2.05, but revision 37.350. And it's that one which has all the IDE problems resolved. We could use whatever size of CF card or IDE drive that we wanted. Well, there it is, all back together. The case cleaned up not too bad. Got all the dirty marks off it. We were missing the trapdoor, so I 3D printed that thing, although it's not great, to be honest with you. Maybe if anyone had an original trapdoor and would be willing to part with it, I would be forever grateful. If anyone has one up for sale, please get in touch, let me know. About the only thing I wasn't able to get off it is that bit of pen there where somebody had wrote colour problem on the original Commodore label. That won't come off, and I didn't want to use anything too harsh that would potentially damage the label itself. But the rest of it did clean up okay. Yes, it has yellowed a bit, and that new keyboard I put in it is equally rather yellow, but I think it looks grand. But the only damage on the case is at the front here. Someone has obviously put in the wrong size of screws before. So you can see where screws have tried to protrude through the case at one time in the past. But look, there's nothing we can do about that. Overall, I am really happy with how this little Amiga turned out. And finally having an A600 in my collection, well, that fills out all of the wedge type Amigas. Because we've got a 500, 500 plus, 600, and 2 of the 1200s. So what do you think I should do with this machine? Other than that 1 megabyte chip RAM upgrade, it's pretty stock. Other than that, it would need that ROM upgrade if we wanted to put a CF card in it. But is it worth putting an accelerator in it? To be honest with you, I'm not sure. Because I do have both the 1200s, one with an 030 and the other with now the 060 accelerator. The CD32, it has the 030 accelerator as well. So I'm not really sure what to do with this. If anyone has any ideas, please let me know in the comments down below. But that is it for this video. So thank you very much for watching. If you enjoyed what you've seen, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.